So what's the best green remodeling resource for homeowners? I worked on a project with the U.S. Green Building Council and the American Society of Interior Designers called ReGreen. And it's a set of residential guidelines that were developed specifically to address the issues around residential green remodeling. It comes in a hard copy that you can download off the internet, and if you print it out, it's this beautiful 2-page document. Or you can go to the website regreenprogram.org and work with the tools that they have that are online. Over here you can see the Green My Project. You can actually, in this drop-down menu, pick your project, like kitchen, and it will sort all the strategies and only pick out the green remodeling strategies that apply to kitchens, right? Or if you're going to redo a foundation, you can click on foundation as a stage of the project, and the only strategies that come up are ones related to your foundation or to your basement. This is totally free. It's online, regreenprogram.org. It's the only resource I'm aware of that's developed specifically for homeowners. So not for building professionals, but for homeowners. You can use this URL down the bottom here, and we'll give you 1 month free access to Building Green. Remember, we don't take any advertising, so half the content you can get to just for free, the other half you have to be a paying member. If you use this code, you'll get 1 month free. And you don't have to give a credit card. You know how that works, right? You give a credit card, but they don't charge it until you forget to unsubscribe. It doesn't work that way. This one, you don't need a credit card, so at the end of the month, it just expires unless you choose to do something else. And our company is for both commercial green building and residential green building. If you gave me your email, we could give you 2 months free on greenbuildingadvisor.com. That is strictly devoted to residential construction. I have no stake in this. They're just resources that you can have access to for free. Ta-da! This is my daughter in Yosemite. So, how much time do we have for questions, Tana? Okay. When people don't have questions, you've either done a lousy job or they're like, oh, I don't even know where to start. The question is, she has a home in Florida where there's concrete block. And the block is what's called ungrouted, which means when they put the block down, they didn't fill those cores. Right? They're empty. That's how my house is. All right. The problem with that technique is that if this is the core, there are concrete members that go from the outside face to the inside face that are called thermal short circuits or bypasses, right? So while there's insulation inside that cavity, there are concrete members that have the inside face of the block and the outside face of the block communicate, right? So spray foam is not inexpensive, and because they're called webs, short circuit, you're not going to get the bang for your buck. That's exactly why I put the spray foam on the outside of my block rather than go into the cores. Okay, so in my opinion, will it improve the thermal performance of your house? Yes. Is it the best way to improve the thermal performance? No, it's not. So yes, you can do it, but it's going to be fairly expensive for what you get out of that technique. So it's tricky. The one thing you can do that's important to improve the performance of a house, regardless of climate, is make it more airtight. Okay? So my question would be, in addition to the value of the insulation, how much will that improve the airtightness of your house? Now, inside that block wall, unless there's step cracks, that's not where the air is leaking, right? So you could fill all those cores. A, you're going to get insulating short circuits through the webs, and the place where you're having your biggest air leakage is not inside that block. Okay? And there's a technique called a blower door, where they put a door in your home and they can identify how leaky your air is and where the leaks are. And the patterns of leakage tend to be around big holes in your house. Like if you have a plumbing stack that runs from, the first floor or the basement right up through the roof, and that's not air sealed, that's like a highway for air. So when you go to evaluate the performance of the house, I'm not convinced, even in Florida, that that's the best bang for your buck. One more thing about spray foam insulation. In Canada, you are not allowed to install spray foam insulation unless the company is certified and the installer is certified. Because the way that you mix the chemicals and the temperature of the surfaces, it's tricky science. It's chemical science. So in this country, anybody can blow foam. And you want to make sure that the spray foam insulator that your remodeler is working with is a licensed contractor for spray foam insulation. And it's not required by law, but you can require it. Okay, so it's important that the people using those spray foams actually understand how the chemicals work. So the question is, how do I find the right person to do this work? We are a national company, so we do not list, we're not like Angie's. We're not like an Angie's List for that. And unfortunately, Angie's List doesn't cover, green remodeling. I still think your best bet is to go to Earthcraft House and look to see if your remodeler is an Earthcraft House remodeler, because he or she can be. So most of the critter problems we have, and I'm talking about insects, carpenter ants up in our neck of the woods, termites, dust mites, and mold and mildew and fungi. If you control the moisture, you control the pest. So part of the reason he doesn't know this, but the reason he doesn't like insulation is because if they're not managing the moisture with the same intensity as the energy, the moisture content of the materials go up. And all those critters love the increased moisture content. So one way you have better control of this problem is that as you air seal and insulate the home, you have to better control the moisture, because if you don't, you're not protecting those materials from the termites. The second thing is that all of the chemicals that we used to do pest control in the past have been particularly nasty. There are now chemicals that are done with bait traps. And what you do is you put in a bait trap with just a bunch of cardboard, right? And you put them all the way around the house. And somebody has to check them. And if you check one and there's termites inside, you take out the cardboard core and you put in one that's saturated with a chemical, a fairly benign chemical, so that when the termites go to that, you are what's called spot controlling the termites, right? Rather than just filling your whole yard and all your building materials with a chemical, this is a bait system that is very targeted to where you might have problems. I don't know if you're talking about Centricon. Like Centricon, yeah. That's a big change, because the other ways we have of doing continuous protection against termites, like the inspection zones all the way around, it is hard to get good air sealing and insulating and also leave those inspection zones open. So my approach is control the moisture, and then you've got the leg up on all those pests, including termites, and then the bait systems are the best that we have. And when you do that, make sure you have a maintenance contract, because if they put them in and nobody ever checks them, that's not going to work. So it has to be a continued approach. So the question is, and this applies to this area, is how do I choose roof claddings to deal with our main problem, which is heat buildup in attics? So there's two answers to that. One is you can buy even asphalt shingles that have higher reflectivity than other types of roof materials. And the Energy Star Cool Roof program has a rating system for roof cladding materials, including asphalt shingles, so that you can pick a material that is better at rejecting the sun's heat as opposed to absorbing it. Now, the problem is that a lot of those roofs are light-colored materials, and we don't care for those. It's not until you get down into the Caribbean that cool roofs that are white become cool, or attractive. Anywhere up from here north, it's like, no, they've got it. White shingles look stupid, right? Pardon me? They show stains. Yeah, they discolor more easily. So that's one answer. The other thing is that you can put a radiant barrier on the underside of your roof, facing down, that is the next best thing to keeping the heat out. So there's two ways to keep the heat out of an attic space. One is to reflect it at the roof level, and the other is to choose a material that's low emissivity that doesn't allow it to radiate down, or as much of it to radiate down. So if you can't change the color of your roof to reject the heat, then you should, in hot climates, you should consider what's called radiant barrier sheathing. And essentially it's a very shiny surface on the plywood OSB, and you put that side facing down. Okay? So the question is, where do you put that? So when they're building the roof, okay, so you're asking about existing. Okay, so it's more difficult to add a radiant barrier to the underside of a roof, but it is possible. Okay? So you can make it part of your recladding strategy from the outside in an existing home, or you can consider a radiant barrier on the inside, but it's of course harder to do after the fact than prior. Radiation is the travel of heat through empty space. So if you put the radiant barrier so it's touching something, it's not a radiant barrier. It has to face empty space. Okay? Shiny surfaces only are what's called low E if they face an empty space. If they're touching something, then you've lost, it's not radiating, it's conducting. Yes. Yeah. And interestingly, you could say, well, why couldn't I put the radiant barrier on the ceiling? Right? And it turns out that real shiny surface, in terms of reflecting radiant heat, you go up there 2 months after you've put down the shiny surface, what's it going to be covered with? Dust. And even a layer of dust so thin you can barely see it can have a 50% erosion of its reflectivity. It's that shiny, clean metal surface, and as soon as you add something to the surface, the emissivity completely changes. So one of the reasons we don't do it on a flat surface is it's got to be kept clean, and the only way to do that in an attic is have it facing down. So the question is, if you had a finished attic space and you're looking for an opportunity to reject the sun's heat when you reclad, you could do this. You could take the radiant barrier plywood, turn it face up, and then create an airspace. Put down another layer of plywood that becomes the nail base for the new sheathing. Now that radiant barrier is facing an empty space, let's say 3/4 of an inch, it'll work. However, it's really expensive to do that because now you got 2 layers of plywood that you're dealing with. So when I teach this topic, heat moves in 3 ways: conduction, convection, and radiation. And on Earth, that's always a complex blend. And so when you ask the question, how do I keep my attic the coolest temperature, we have to talk about all 3 forms of one. So you always go after the one that's easiest, right? And then you let the others do the best job they can. And I guess what I'm saying is if you have a finished attic and you're recladding, you're probably going to have to give up on the radiant heat transfer unless you're willing to put up a reflective material. Okay? Well, thank you.